Is it back far enough where it's getting me and the board? Okay. All right, so like we started out, first thing that's going to be done on any job site, once you determine property lines and that, we'll deal with that just a little bit later here. I got an outside exercise we'll do. You determine where the building or driveway or whatever it may be that you're doing is going to get worked on, or where you're going to build it, and you remove the topsoil. Topsoil has to go. Normally they save that, pile it up, and you've seen that where we visited out there to the farm. Saved it for later. They'll reuse that once the project's towards the end. Why you want to remove that topsoil, if you pour concrete on top of topsoil, that is going to rot underneath that, and when something rots it gets smaller, so what's it going to do? It's going to leave voids underneath the concrete, and then your concrete's going to bust and crack in those spots. Okay, so you would get rid of that. So you've removed your topsoil. So the next step is setting up your building lines. So this is part of the exercise we are going to do outside. We're not going to do this today. So I'm not going to go into great depth with that. But basically, you're taking your area where you're going to build whatever you're going to build, and you're squaring that area up to the size it needs to be, running string lines to where that location is. So we talked about square before. How do you check if something is square? You have this is the same size as this, and this is the same size as this. What do you do to make sure that's square? And square would be, these are 90-degree corners, correct? Okay, how did we go about that? We talked about this a little bit. Anybody remember? All of them need to be 90 degrees. You check the diagonals. This measurement will be the exact same measurement as this. Okay, that's how you check if something's square. If this was a big area, say 40 foot by 30 foot, you can't just use a square like your square or a framing square in this corner. You could get it close within 2 inches out of square with something like that, but you wouldn't be able to see that it's off very much with that little bit of area. So you need to check those diagonals. It's the same way building a floor system or building walls. We'll do the same thing. We'll square those areas up, and we'll see that later on. Like I said, we'll do an exercise with this outside so everybody understands how to do this. So you got your area square here. So your next step is to dig. If this was, say, a basement, you would dig to the depth that you need to be. Maybe it's a crawl space, so it wouldn't be quite as deep. But when you dig for a crawl space or a basement, you have over dig. So you would dig it way out here, okay? Leaving usually 2 to 3 foot room to work down there, because you need room. Whether these were poured walls or if they were block walls, you need room to work on the outside also. So it's called over dig. So you would dig this way out like that, okay? Then after that was dug, you'd have to get down in the hole and reset these lines up down low so you could start setting for your footers is where you would start. So I know you guys did the chapter a little bit that day you worked on. Not quite how I wanted you to do it. But you should have a little bit of information. So, talking about footers, can anybody explain to me what the footer is? No, nobody remembers what a footer is? All right, so I'm going to draw a picture just of one wall. So we have a wall here, say it's a basement wall. It's coming up like this and down, okay? What the footer is down at the bottom, this wall has to set on what's called a footer, okay? And it's concrete. You can see it's bigger than the wall. Okay, does anybody remember how much bigger than the wall it has to be? If this was an 8-inch wall, say it's going to be a poured wall. They're going to pour a concrete wall, which means they'd have to set forms up and that. And we're not going to go into that great a depth. And you guys will kind of see that when we go on our visit out there when they pour walls, how that's done. The footer has to be, normal is 8 inches thick. So it's 8 inches this way. But normal width is twice the width of the wall. So if this is 8 inches, how wide does this have to be? 16 inches, okay? Today, most walls are 10-inch walls. So if this was a 10-inch wall, what would this have to be? 20 inches, okay? So that's what you would have to set your forms up as for 20 inches. Now you can also see that the wall, I didn't quite draw it right, but it should be fairly centered on this footer. So you can't have your 8-inch wall. It's real picky where these footers go because you wouldn't want it your wall way out here to the edge. It's got to be roughly centered. So 8-inch wall, you poured this 16, how much does that leave on each side? 4 inches on each side, right? 10-inch wall would be 5 inches on each side. So that's going to vary, but you got to take that into account when you're forming this stuff up. It's formed up with 2x4s normally, or 2x. It doesn't have to be the whole, your forms don't have to be the whole 8 inches thick because it's got to be 8 inches thick. You could form that up with 2x4s or 2x6s, and then once you got your form set, then you just dig down a little bit deeper to get your whole 8 inches. All that's got to be formed is kind of the top, so you can tell grade. Say we're working with a pole barn. Okay, so we got our square area up here. Poles are normally 8 foot apart, so you got a pole here. Out here at 8 foot, you got a pole, and then another 8 foot, you got a pole, and then you got a pole here, and then right in the corner, you got to have another pole. Okay, you're using 6x6 poles. So they're roughly 6x6, they're actually 5.5 by 5.5. But so you go 6x6. So how big would that footer have to be for that? Because you have to have a footer below your pole.
Maybe 11 inches?
Well, if they were 6 inches, you're figuring them at 6, they got to be twice that, right? So 12 inches. So that means when you do a pole barn, same system, you set your lines up, you got lines going across here, but now you have to dig these holes on these 8-foot centers. These holes would have to be 12 inches in diameter, okay? Why do you have to have a foundation of some sort? That's kind of what we're dealing with, whether it was a basement or if it was poles going down in the ground. Basically, it's supporting the building, but you're also getting that down below the surface of the ground. And this is real critical in Michigan or a colder state. What happens in the winter is you get frost in the ground, okay? So say you got a pole barn here and you only take your pole down 2 foot in the ground, okay? Not only is that not going to be stable this way from blowing around, but also frost has been known to go in the ground 36 inches. Don't stop that because it's going to mess it up. Yes.
Do you have any airline hose cutters?
I do not. Sorry. Frost goes in the ground. If this is only 2 foot deep, frost is going to get in the ground, and when frost gets in the ground, it pushes stuff around, okay? So it would shove this up, and if this is your pole going up in the air supporting your roof, right, it's going to shove, and it may not shove the same everywhere, it's going to shove that part of the roof right up in the air, and it's amazing what frost will move weight-wise. It would push that right up and rip the steel right off that building, and I mean, that little bit of weight wouldn't stop it. It wouldn't matter if it was a shingled roof. It would just push it and rip sheeting and whatever. So you got to get down below that frost line. In Michigan, does anybody know what it is, how deep you have to go?
6 foot.
It's not 6 foot. 6 foot though is good for water lines because it does get really cold in the ground. So water lines, buried water lines, like to a barn for them outside spigots, usually try to bury them more than 4. But a lot of people like to take them down to 6 so they don't freeze up on them. But 42 inches is code in Michigan. You have to be down at least 42 inches. Of course, a basement would be a lot deeper than that. If you had 8-foot walls down there, you got 2 foot of your foundation sticking out, it's probably 6 foot in the ground. But it has to be a minimum of 42 inches. And that doesn't matter if it's a pole barn, if it's just a garage, separate from a house, or a garage attached to the house. It has to be that low. So, any questions on that, anybody? So we're dealing with our concrete section. Another thing I want to talk about here, and we'll see it once we go out in the shop. So you have your footers here. So your building size, and then you frame this in with 2x4s like this, and you're going to pour concrete between this. There's your footers. Another thing that has to be added to these footers, it's code in Michigan, you have to put what's called re-rod or rebar. And I'll show you what that is once we go out there. But it's just a round rod. You can get it in different sizes. Comes in different lengths. Usually when you get it like from a concrete company or something like that, usually comes in 20-foot lengths, but they'll cut it what you need. You can grab it and bend it. There's 3/8 rod, there's 1/2 inch rod, there's 3/4 rod, there's 1-inch rod. Of course, the bigger it is, the more expensive it is. Normally, people are using 1/2 inch rod. But you have to put this in your footer. And so you pour your concrete, but while it's still wet, then you usually have this stuff kind of pre-bent up and thrown to the side, and you just set it in there. Normally, they'll bend it around the corner, so you can just step on it and grab a chunk of it and bend it up like this, usually 4 foot or something. So you got this re-rod, and you just drop it in your concrete and push it down until it's about halfway in the concrete. And that just helps tie everything together. Once that hardens, it hardens around that rod, and it keeps your footer all one piece rather than something dropping off and something. So you got this, and you usually try to break your seams up. So this one you may run all the way here, and you got to put 2 chunks in, kind of space them out in your concrete. So you have that running all the way around for reinforcement. Okay. It's really critical that, especially like on a basement, that this stuff is level. Okay. I mean, if you had it sloping, that's what your house is going to look like, or your garage, or whatever you're building. It's real critical that that's the same elevation here at this point at the top of it that it is here. Okay, if you didn't have them right, that's how your house is going to look. Okay, so you don't slope a foundation, but if you were pouring flat work like a driveway, you may want some fall. Say you wanted the water to fall this direction, so you'd have some fall coming so the water, when it rained, would run off. A lot of people slope their garage floors because you pull in with a vehicle with snow on it. You don't want that to just lay there on the floor, all that water. Normally they'll slope them towards a door, or they could put a drain out here and then slope this down this direction towards that drain. So that kind of stuff does get some slope to it. Footings have to be square also. It's, you know, the most important step. I mean, when you're building something, if your footings and your foundation are level and square and to the right size, it makes the building go easy. If it's out of square or out of level, it's going to make the building go bad the whole way through, right up through the roof. You know, the walls, the floor system, everything's going to be harder. And then on top of that, it's not going to be right. You know, it's not going to be to the right size because you had it out of square. So that's important. Sometimes, does anybody have a walkout basement? Or do you know what I'm talking about, a walkout? Where part of the basement's in the ground, but then part of it you have a door and you can walk right outside from the basement. That's called a walkout. And it's all on the contour of the land. You know, if you had a hillside here and you were building on that, you'd have a walkout. So say you have a building here, and you'll see this over here. I think they have to do some of these. So say this is all higher ground here and it comes around and then it slopes off on these sides. Remember that footing has to be in the ground how far? 42 inches. So say this is your walkout part and everything else is, you know, 6 foot in the ground at least or whatever. But this area here is exposed to the ground level in your basement. What has to happen here is you have your footing for this here all the way around, the same thing here. But this footing through this area has to be, these would actually stop here, okay? These here would have to be dug down another 42 inches deeper. It's called a deep footing. And I think they're having to do one of these over there, so we'll get to see that. Another thing that has to happen to protect this, and usually a deep footing, they don't really form them. They just take a backhoe, or you could dig it by hand, I guess. It wouldn't be any fun. But you would dig that down, and you don't form it or anything. You just let the ground be your form. But you have to dig it deep enough that you can put an insulation, usually foam, down in there on this outside edge to protect that from the frost up higher, okay? So you have to insulate that, and I think we get to see that over there, so I just wanted to mention that. The last thing I have for in here that I wanted to cover, and then we'll go out into the shop. Does anybody from doing what you did in the chapter, or does anybody know what is in concrete? What is concrete made of? Go ahead, one at a time. Rock. It has some kind of stone in it. Okay, so you have stone, which is also called coarse aggregate, is what the book says. So it's got a coarse aggregate in there. What else is in there? Cement. Okay. What else? Water. One more thing. Sand. It's going to have some kind of sand, which is fine aggregate. So you got sand in there. Now these got to be proportioned right. We're not going to really get too critical with that. But you can hand mix. You can buy cement in a bag. You can buy stone, have it delivered. You could have sand delivered, and you could mix it, okay, by hand. And I don't know, some of you may have seen those tub things that spin around, and you could hand mix your concrete. It's a lot slower process. Everybody that's pouring something orders it from a ready mix dealer, a concrete company, and they deliver it in a truck and do this for you. And it's usually a lot better concrete than what you could make. There's a little bit more science to it than that. They get really picky with it. Concrete can be ordered in different strengths, okay? That's all on the amount of cement that gets put into it, okay? They call it 6-bag. So when you call an order, it depends on what you're pouring. If you're pouring something inside a building, would it need to be as strong as something that's going to be out in the weather? Probably not. So you usually downsize your bag, maybe 5-bag for this, for something inside like a garage floor or a basement floor, pole barn floor. Unless you're pouring heavy equipment on it, you might want it stronger though. You could get 6-bag, 7-bag. The more concrete that's in it, the stronger it's going to be. So that's the 3 or 4 things that are in it. Talking about the stone a little bit. This is pretty critical. Another thing that adds strength to concrete is what kind of stone you put in it. Okay. 2 choices. You can either use like a round stone or you use limestone. Which one of these do you think would make stronger concrete? limestone, does anybody know what limestone is? A lot of times people have it in their driveway. It's not round, it's like, you know, it's all like jaggedy and has flat edges. Limestone is stronger. And the reason being, it's there to add strength. The cement bonds to this. And of course you wouldn't want that right up on the top, and we'll show that out here in the shop, and they kind of talked about it on that movie you guys watched. But limestone has all these flat edges. Well, that concrete or that cement can bond to this a lot stronger. Does that make sense? Because it's got all them flat different edges. It bonds to that stronger than it does something a round surface. It could come off this easier. So normally, with anything that gets poured outside, a driveway or anything like that, a parking lot, anything that's outside that gets poured in concrete is done in limestone. Usually inside pours, unless, like I said, you were pouring a pole barn floor and you're pulling tractors and that kind of stuff in it, heavy equipment, you might want to use limestone in that. But most inside pours, garage floors, basement floors, that's done in roundstone. Which one do you think is cheaper? The round stone, of course, it's cheaper, yes. Yeah. And that's why you try to cut the cost down but still have it sufficient for what you're doing. But you don't want to use this inside if you don't have to, because it ups the cost of the concrete quite a bit. So I guess that's all I have for in here. You can go ahead and shut that down and then we'll move it.